Hello. About 10 years ago, I installed a chimney heat pipe in the in our chimney. This is the visible part. It's the condenser. The video I made wasn't all that clear, and it gave me a few extra. There's a lot of questions about it. So in this video, I'm hoping to explain why I put it in our chimney and how it works. Basically how it works and any lessons I've learnt from it. The link for the previous video which I posted 10 years ago and really wasn't very good, is hopefully in the description. The reason I made the chimney heat pipe is I was working for a company called Solar Systems, who made large dishes that track the sun. They were 8 metre in diameter and multiplied the sunlight 500 times. At the focal point were concentrated photovoltaic cells, and these cells converted about 1/3 of the energy from the sun into electricity, which meant there was 2/3 of the energy which had to be dissipated. It's fairly low grade heat, very low temperature. We're aiming for 65 degrees of coolant, which is really low. You can't do too much with that energy. So my job, I was the thermal cooling engineer, actually called principal thermal cooling engineer, which I quite like the idea of being called a principal. And I was looking at different ways that we could dissipate all this heat. The system I inherited was a cooling skid that sat on the ground. The cooling skid used a lot of energy. It used 1,000 watts to run the fan and 1,000 watts to run the pump. I did a few improvements on this by taking it off the ground and putting it onto the back of the dish. Hope I'll find some pictures of that. And that reduced the total energy down to 300 watts from the original 2,000 watts. But I thought I could do better, because if we used a looped heat pipe like the one here, then there's no pump, which means you eliminate that altogether. And if you size the heat exchangers correctly, you could have very minimal fan required. So I was hoping that the focal point of the dish would also be where the looped heat pipe would be. So before I went too far with that, I thought I'll see whether I really understand the technology and build one myself. So that's what this is. That was the purpose of it. It may have put a little bit of heat into the top story of the house, but not really. Wasn't that much. The temperature of the condenser behind me, that never reached 100 degrees. It was because you could always put your hand on it, which is just as well, because you don't want to burn yourself. And it was exposed. My children who play video games up near the condenser, they told me that every time the fire started down below, there'd be normally 3 bangs while the coolant started to flow, and then it'll just keep flowing. I'll try and explain how the heat pipe works. I've done a simple slide show thing. The first slide shows that the grey bit is the chimney, and with the fireplace at the bottom. So there's nothing. That's all fairly simple. Second slide, this shows the condenser, which sits at the top of the chimney, and that's the bit you can see. At the bottom of just above the fireplace, is the evaporator. The evaporator I made out of copper pipe, which you can buy at your local hardware shop, and I stitched it all together with copper wire, so like fins. I thought this might get filled up with creosote, but even if it does get filled up with creosote, then it'll be hot creosote, so we're still getting the heat out of it. and it sits next to the coolant, next to the ducted air going up, the flue. It doesn't actually block off the air. So if I was going to do it a bit better, then maybe I'd have the air flowing through the chimney, passing through this instead of past it. There's two pipes that connect the condenser to the evaporator. One I've called the gas pipe, and the other one I've called the liquid pipe. The liquid pipe connects the bottom of each heat exchanger, and the gas pipe connects the top of each heat exchanger. So I've put a fire at the bottom, so when the fire heats up, it boils the water which sits in the bottom of the evaporator. Now this is the amount of coolant which sits in the system. I measured the volume of the system and it's 9 litres, and I know I didn't want it all to be liquid, I wanted it to be two-phase. So it had to be, I had to stretch, I eventually found out there was about 2 litres into the 9 litres, and the only way you could do that is to vacuum out all the air and then let 2 litres of water suck into it, and that 2 litres had to become vapour to fill up the whole 9 litres. So it's not pure liquid. If it was pure liquid and I heated it up, then the liquid would expand and the whole system would burst. But clearly that doesn't happen. So I had to vacuum it down to near perfect vacuum to get to make sure they've got any moisture which was in there already out. And I used a refrigerant pump, a pump that's used in refrigerant systems or refrigerant charging systems. It's a vacuum pump. And I made sure that I had a little reservoir to make sure that the water didn't go straight into the vacuum pump, but got collected into a little reservoir before it got into the pump. And this allowed me to have two-phase fluid through the system. So the way it works is that the vapour boils at the bottom, so there would be liquid in the system, and any liquid would be sitting right at the very bottom, and that would boil, change state, which means it starts to expand and becomes a vapour, and there's not enough space for the vapour the vapour has to move somewhere because it's now expanded, and the expansion means that the only place for it to go is up. So it flows up through the gas pipe to the condenser, and in the condenser heat is removed from the refrigerant, and it condenses, so it becomes less dense, and so it falls down to the bottom and then of the condenser, and then flows through the liquid pipe down to the bottom of the evaporator, where it heats up again and flows through continuously. So that's where you get the movement of the fluid without any pump. The fluid I used was water, and water normally boils at 100 degrees Celsius at atmospheric pressure. So if I wanted to boil, which is making it into a vapour, at say 20 degrees when I'm charging up the system, then I have to get it close to a perfect vacuum to do that. I think that's how it works. Okay, and the last bit is, this is what I've learnt. I originally thought that the pressure would be really, really high, so I got myself a pressure relief valve. So something like 15 bar. I now realise that if you look at the pressure gauge, it's probably not so accurate at the moment, but it was very lucky to get the pressure up to atmospheric pressure. It stayed below atmospheric pressure pretty much all the time. So I removed the pressure relief valve. And so that was the first thing I learnt. Second thing is I had too many connections in the system. Every connection is a possible leak. So I've taken out every possible connection I could find. And just the, I've got, where's my finger? Got the valve to charge it, pressure gauge, and then connections to connect the pipes up. And that's all I've got. So if I was going to do it again, I'll probably have even fewer connections. I think I mentioned this before, that you can hear the water boiling, the liquid which sits at the very bottom. You can hear that boiling and trying to get past the rest of the liquid. And that's where you hear often just 3 bangs, and then the whole thing starts flowing. The temperature of the condenser, it's never above, you can hold your hand onto it, so it's probably about 75 degrees. You can see by how it's built, it was an old condenser I got from Solar Systems. It was for cooling down a very large focal point for a heliostat. And that's why it's made like that. It wasn't made to conduct heat from a refrigerant to air. If it was going to do that, then you'd need a lot more surface on the air side. So you need to have smaller tubes and a lot more fins. So that's something I would have done if I was going to do it again. That would pull a lot of heat out. I'll imagine I'll put a very simple variable speed fan on the back of it to push the air out. Now that would start heating up the room. It'll drop the temperature of the average temperature of the refrigerant, which will be, it'll collect more refrigerant in that way from the evaporator. So if I was going to do it again, I'll get a better condenser. Although this one looks really cool. It looks more steampunk. I think my wife likes that. It's been going for 10 years now. I thought the creosote might build up around the evaporator, but nothing's happened. And it hasn't worn out. I'd probably have recharged it about 3 or 4 times. Mainly more curiosity of how much is in there and trying different charge quantities to get it right. It's still holding pressure. It's all vacuum. So it's holding okay. There's no reason to take it out. It's just a novelty now.